Good afternoon, my YouTube viewers. In this video, what we're going to be talking about is the t-distribution and how it relates to hypothesis testing. So the t-distribution is a probability distribution that is symmetrical and similar in shape to the normal distribution, but it has heavier tails. It is characterized by degrees of freedom, which depend upon the sample size. Okay, so we've got a practice question for a one sample t-test, and we're going to test whether a new teaching method improves test scores in a class of 20 students when the population variance is unknown. So the first thing that we're going to do is our values from D5 to I think it's D24. We have our test scores, our values, and our null hypothesis is a mean of 75, and an alternate hypothesis is a mean of greater than 75. So an alternate hypothesis can be depicted as either H1 or HA. So your alpha, which is your significance level, is 5%. Your population mean is 75. Your sample size is 20. Your sample mean is 78.2. So automatically you know that the sample mean is greater than the population mean. Sample standard deviation is 12.344. We use the formula STDEV brackets D5 to D24. Degree of freedom is 19 because you use behind minus 1 is 19. So that's your degree of freedom. Confidence level is 95%. Your t-test statistic is B10 minus B8. So that's your sample mean minus your population mean, divided by B11, that's your sample standard deviation, divided by square root of B9, and that's 20. So you get a t-test statistic of 1.159. Our critical t-value is t.inv 2t. 2t means it's two-tailed. B7 is your alpha, that's 0.05, and B12 is your degree of freedom, and so that gives you a critical t-value of 2.09. And then your p-value is t.dis.2t. So again, the t means it's a t-distribution, and the 2t means it's two-tailed. So ABS 14 is your t-test statistic, and B12 is your degree of freedom. So you've got a p-value of 0.26. So right there we can tell you, because the p-value is greater than 0.05, you know right away that the null hypothesis is going to be accepted, or they're going to fail to reject the null hypothesis. So then we check our critical t-value 2.09 minus critical t-value negative 2.09. Test statistic 1.15, and outcome is failed to reject the null hypothesis. And the reason for that is because the null hypothesis is greater than 0.05, and come over here to the interpretation. So if ABS B14, that's your t-statistic, is less than ABS B15, that's your critical t-value, you're going to fail to reject the null hypothesis. Otherwise, you're going to reject the null hypothesis. So they're working on absolute values in this particular question. So the thing is what we're going to do is we're going to do the test scores. And so you've got we had to base it on a normal distribution because it's hard to do it on a t-distribution. So this is actually based on a normal distribution. But you see, blue is your normal distribution, red is your positive critical t-value, which is negative 2.09, and then it says gray is your, no, positive critical t-value is 2.09, and it says gray is minus critical t-value, negative 2.09, but the dot is gray, but the line is actually red. So, but we can do this. So there we go. Now we've got it as a gray. And then your green is your t-test statistic. And you see that your t-test statistic is 1.15, and the t-test statistic is less than 2.09. And your t-test statistic is between the negative critical t-value and the positive critical t-value, which means it falls within the 95% region, and so you fail to reject the null hypothesis. So that is how you perform a hypothesis test with a t-distribution, although we had to do the t-distribution with a normal distribution because it's not practical to do this chart with a t-distribution. So that concludes the video on how t-distributions relate to hypothesis tests. The next video is going to be on a chi-square, so I hope you decide to watch that video.